Hello, pre-calculus students. Welcome to your first virtual lesson of the year. Technically, you guys have done this before, so it shouldn't really be that new, but just a heads up about what's going to be coming up. So hopefully you turned in your chapter 2 to 3 review. I'm going to pick 2 problems just to grade on accuracy since we're not going to actually have our test. In fact, most of the assessments that I give you are going to be like really short, or they'll be via quizzes or go formative. So it's going to be pretty different than what you're used to, but hopefully it'll be kind of nice because you can technically use notes and all that on it. So what we're going to be doing this week is we're going to start out with these notes on counting principles for probability. This whole unit is probability. We're going to go through probability and what are called sequence and series before vacation. So we're going to start off with this, and then I'm going to have you try a little activity. You're basically playing rock, paper, scissors. You can either choose to do that with someone if you have someone at home that you could play with, or you can use the simulator I posted. So watch this first, then do the rock, paper, scissors activity. Then there's a little Big Bang Theory episode that I posted a clip of that I want you to watch and think about how different the sample space of that is going to be. So they should be pretty straightforward. The rock, paper, scissors activity, I'm not going to make you post on Classroom. You're just going to practice it as an activity. But then you guys will have homework, which is a worksheet that I posted as well that I want you to do either using Equatio. If you already watched the video, you can do that. Or if you want to just do it on paper and then post pictures, that works for me as well. And then I'll post answers to that on Tuesday. So we're going to just do probably about half of these notes today, and then the other half we will actually do tomorrow. We're going to start with just selecting things at random. So our first question is, and these notes are on Classroom as well if you want a larger version of them, but you put 8 pieces of paper in a box, you number them 1 to 8, you draw 1 piece of paper at random at a time, record its numbers, and the key word here is it says, and replace the paper in the box. Then you draw a second piece of paper at random and record its number. Finally, add the 2 numbers. So how many different ways can you obtain the sum of 12? The easiest thing to do with these is literally list out all of your options you have. So when you're putting things back, sometimes it helps to make a tree diagram for this. So your options when you pull the first number are going to be 1, 2, 3, 4, 5, 6, 7, 8. Your second number that you're going to choose, you literally have 8 numbers again, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, and so on. So you're going to literally have 8 branches off of each of those scenarios. Then I usually like to label it as, if you choose a 1, a 2, 3, 4, 5, 6, 7, 8. And then your second number you have to choose from is 1, 2, 3, 4, 5, 6, 7, 8. So what I want you to do is just list out all the numbers that you see. You would have to complete the whole tree diagram to do that, but you don't really have to do it if you can just think about it. All of the numbers that could add up to 12. So take a second and see if you can try that out on your own paper. Again, if you haven't printed the notes, that's okay. You can just do this on scrap paper as well. All right, so hopefully you got a few different options for your first number. So our first number, you have numbers that could add up to 12 being 4, 5, 6, 7, and 8. The reason you can't have any lower is because 3 plus none of those numbers would actually give you a 12, right? Your second number is going to be, from there, 8, 7, 6, 5, 4, because these sets of numbers all add up to 12. So you technically have 1, 2, 3, 4, 5 different options that you can get. So you have 5 ways that will get you 12. The difference happens when you have something where you do not replace the numbers, right? So this option, we technically had, let's see, we had 8 numbers in the first draw times 8 numbers in the second draw. So you had 64 outcomes total. Notice I just took 8 and multiplied it by how many options you get in the second time, which is 8. Only 5 of those options would give you 12. If I asked you to find the probability of getting a 12 as a sum, it would be 5 out of the 64 total options you get. Okay? So because of the options, you had either a 1 and a 1, a 1 and a 2, a 1 and a 3, like all those options work. Notice a 4 and an 8 is different from an 8 and a 4. Okay? If you don't replace those numbers, it becomes a little different. So you only have these options now, because if I draw the tree diagram again for you, notice things are going to change a little bit. Usually in a tree diagram, you also want to list out the probabilities. So like literally getting a 1 in that branch, I'm going to go back for a sec so you can see it. But getting a 1 is a 1 out of 8 chance, right? Getting a 1 again is a 1 out of 8 chance because you still only have 1 out of 8 numbers. But the probability of getting a 1 and a 1 is 1 out of 8 times 1 out of 8 because it's both probabilities multiplied, which is again 1 out of 64. Anyway, that's a quick lesson in tree diagrams. Those of you who take stats already knew that. But if you don't replace a number, what happens to your outcomes is it actually reduces by quite a bit. So what you'll see is if I did not replace numbers, I'd have 1, 2, 3, 4, 5, 6, 7, 8 options, right? Just in total, not worrying about the 12 yet. But what happens is if you do this without replacement, you take out like basically half of those options because and we can, estimate what that is for now, but we can see it. So now I took out the 1, I can't put it back. So now I only have a 2, 3, 4, 5, 6, 7, 8. I can't use the 1 because I already held it out. Right? And then if I have a 2 first, I now have a 1, 3, 4, 5, 6, 7, 8 options. So I went from 1 out of 8 to now, these are all going to be 1 out of 7 options instead. So if I wanted to find the probability of each of those outcomes, I would do 1 out of 8 times 1 out of 7. The probability of getting a 1 and a 1 in this scenario is 0 because you are not replacing it. You're not putting it back in the box or bag, whatever you're looking at, okay? So if I were to list out all those outcomes for this, notice you can get a 4 and an 8 and an 8 and a 4 still, right? Because those are 2 different scenarios. But what number are you now missing? A 6 and a 6 you can't do, right? Because if you take the 6 out, it's not possible anymore. So now you only have 4 ways of getting a 12, okay? So that was a super fast lesson in with and without replacement and a little bit of tree diagram stuff. Just so you know, if I ever were to write a sample space, which we're going to do more with later, but a sample space for my first number would literally just be 1, 2, 3, 4, 5, 6, 7, 8. If I asked you to list the sample space for all of the numbers, you'd actually have to do every combination, which I would not have you do for this scenario because it would take forever because you'd have to list out 1 and a 2, a 1 and a 3, and so on. So I'm not going to do it. All right, fundamental counting principle. It's awesome. So this is actually the most basic of probabilities, which is what you guys are actually used to. Something to notice is that the number of ways to figure out 2 events that can occur is literally just multiply the number of outcomes. You'll see this in a second. But it says how many different pairs of letters from the English alphabet are possible. So what that actually means is taking 2 letters in our alphabet and seeing if they can pair up. So think of how many options you have for the first amount of letters. This is very similar to the last question we just looked at, actually. So you have how many letters you can choose from? There are 26 letters in the alphabet. And if you don't care about repeating, how many options do you have for your second letter? 26. There's a pattern here, so it's 26 to the second. So notice the pair part is up here, and then the number of letters part is down there. And that actually ends up being, just so you know, 676. So there's lots of different ways that you can make different letters happen in the alphabet. Hence why you guys, when you make passwords, have to give 4 different letters. One's capital, an exclamation point, a number, the name of your firstborn child, all of that in your passwords. Just kidding. Okay. Sorry you can't slide the answer slide. I wish I could do that too, but unfortunately I'm not using Smart Notebook on this, so I can't slide it out like normal. Okay, I want you to think about this question, try it out on your own, pause the video, come back, and I will have done it for you. Okay, so this one's a little tougher because they say that you can't use a 0 or a 1 to start with. So just so you know, usually we have 10 digits because we go from 0 all the way to 9. So they count 0 as a digit as well. But if the first 2 numbers cannot be a 0 or a 1, your options are only 2 through 9, which means you have 8 numbers for the first spot. What about the second spot? Yeah, that's right, you can have 10. Third spot, 10. And then it says you have 7 digits. So that means, just so you know, if you didn't see this before, that says within each area code. So we don't actually care about the area code. This is like our first 3 numbers of our phone number. Then the last 4, again, they don't care about what numbers. You don't have to worry about repeats. So it's literally 10 times 10 times 10 times 10 options. This is not a subtraction sign. This is just showing the separation of those numbers. So if you were to list this out, the easiest way to do it is write 8 times 10 to the 1, 2, 3, 4, 5, 6th power. And that ends up giving you 8 million, which they need because there's a lot of people in the United States. And it's within each area code. So they give us a lot of options. Now we know with cell phones it's going to be a little bit different because area codes don't work exactly the same as they used to. Like I have a New York area code, but I'm living in Connecticut, if you were unaware. So it's going to be dependent on where you get your phone from, basically, nowadays. Alrighty, so we are moving on to permutations. Just kidding. We're going to do that tomorrow. So you are done with your video for now. Make sure that you complete the Big Bang Theory video after you do the rock, paper, scissors activity. I'm not going to have you turn in the rock, paper, scissors, but I do want you to do it because it's a little bit of like classwork, like practice, and it's kind of fun because you get to play rock, paper, scissors. The Big Bang Theory clip is just to show you that there's going to be more options with what they use as their rock, paper, scissors. And then your homework is a little fundamental theorem counting homework paper. So that I am going to have you do either an equatio if you want to, or you can just put it on paper and take a picture and upload it onto Classroom. Anyway, enjoy the rest of your day. Thanks.